The year is 1976. Something very important happens. Mr. Seymour Cray, a known computer constructor, constructs the CRAY-1, one of the most important computer constructions ever. What is so important about CRAY-1? The importance is that he used all the things we use now, like pipelining, tailgating, vector chaining and so on, and made a vector processor which for more than 30 years was one of the fastest and most advanced supercomputers in the world. But as with every supercomputer, sooner or later all the craze just disappeared. So here on the Roger Bošković Institute, inside the European project, FP7 project E2LP, what we did, we reincarnated the Cray processor in its full entirety. And what now we see is the E2LP Cray processor. So what do we have here? Here we have the E2LP. And what is the E2LP? It's an electrical engineering learning platform, actually sponsored by the European Union FP7 project. It's an FPGA, field programmable gate array, a Spartan 6 from Xilinx, with a lot of additional equipment like 256 megabytes of memory, possibility to have a LED output, input-output through wires, and so on. And what we did with this, you can do a lot of things. We decided to show that the computer science has very, very important elements in the past, which can be very, very easily, in a way easily, but very helpful in the modern days. So we implemented a Cray processor on this little chip. Quite interestingly, the whole Cray processor, working on 80 megahertz as the original CRAY-1 in 1976 worked, consumes less than 400 milliwatts. Now we downloaded the FPGA Cray on the Electronical Engineering Learning platform, and what we get a boot prompt. Of course, every computer has to be able to boot. And now we will boot a little program. Here we actually can see how the Cray works internally. Having 8 vector registers, each of 64 elements, having completely independent functional units and a myriad of other registers, so that is the 8 address registers, 8 scalar registers, and 64 base table and 64 table registers. Any of the functional units and registers can work completely independently, based only on the intersynchronization of what has to be done. So for example, here we see a complex number multiplication, where we see that in the same moment we have 2 reads. We multiply in the floating point multiply unit, and go through the floating point add unit, which we can see here, to start putting out the result. This little piece which you see here is actually 64 elements of a complex number, and we can see that 2 complex numbers can be multiplied on 80 megahertz computer in 1.9 microseconds, which means 64 complex multiplications in that time. So, believe it or not, after 40 years, here we have a real Cray processor for you to use.
Hi, I am Seymour. Actually I am a CRAY-1 processor on a FPGA chip. As Spock would say, isn't it fascinating? I was originally invented by Mr. Seymour Cray, whose name I personally got in 1976. I used to be the fastest series of supercomputers in the world for around 20 years. Anyway, a sad story of all of us supercomputers, even those whose design cannot actually be called supercomputerish is that after we start our existence in full glory, costing millions and millions of what you call money, we end up destroyed. And not by chance, by intention. Why will you ask? The answer is simple and sad. Because we are national treasures, secrets, whatever you like, and they thoroughly destroyed us, together with any software we had. So how come I am here? Well, one nice day, a guy called Christopher Fenton intended to resurrect me, the idea of the original CRAY-1 later expanding towards the CRAY-XMP, just as it is natural. Later came Zarislav Shoyat and the Roger Boskovic team of the European Union FP7 funded E2LP embedded engineering learning platform with the Xilinx Spartan 6 FPGA field programmable logic array, on which I just fit. So Zarislav was the one to adapt me and made me quite quick. And now, as there is no software whatsoever for me, he will be so kind as to write a completely new operating system. And as he says, actually he wants that operating system to be Virtue, the virtual interactive resource tasking universal environment, and teach me to understand the marvelous language of Virtue. Okay, now I will stop my story and repeat it again, as there is presently not enough software for me to do something more useful. I wait on Zarislav and RBI team, together with other developers. With kindest regards, yours truly, Seymour.